Okay, good morning to all. Welcome back. Today going to discuss about chapter number 4, device management of operating system. Before going to discuss about this chapter, let's talk about the articles of this chapter, techniques for device management and device allocation consideration, IO traffic control, IO schedule and IO device handlers, and last one is pooling. So, what is the device management system or the IO management system? The main function of all the device managers are monitor the status of all devices, including storage drives, printers, and other peripherals. That means it should be manage all the input-output devices which are connected to the system, and that is done by the operating system, and it is known as the device management system. And enforce preset policies on which process gets which device for how long. Deal with the allocation of devices to processes. Next, deal with the deallocation of devices to the processes, both at a temporary basis, when the process is interrupted, and on a parameter basis. When the process is completed, there are three main types of devices. One is your dedicated devices, another one is your shared devices, and last one is your virtual devices. So first come to let's discuss about the dedicated devices. Generally, the dedicated devices that are assigned to one process at a time, and the process only release the device once it is completed. That means a particular device is purely dedicated for a particular system, a particular process. After the completion of the job, the process will release that device. Next is this makes sense for devices like flutters and tape drivers. The problem with this is that it means only one user is using it at a time, and it might be inefficient if the device is not being used 100% of the time that is being logged by the user. That means in dedicated devices, it is purely dedicated for a particular process. And there is number of like printer, plotter, everything. But here problem is that if the process use that device 100%, or you can say the user using at a time, and it might be inefficient. If the device is not used 100% of the time, that is being logged by the user. If the process is not used that device frequently, that means it is the wastage of time or wastage of the sharing of that device. Next is a shared device. These are devices that can be shared between several processes. For example, like a hard disk, right? It is a share but interleaving between different process requests. Shared device means, example, a hard disk, it is a shareable but interleaving between different process requests. It is shareable device. And number of processes, not only used by one process, number of the process used the same hard disk, and this is the shareable. All conflicts for device need to be resolved, but predetermined policies to decide which request is handled first. That's the shared device. That means shared device means what? This is shared by different type of process. But here, to avoid the confliction or the confliction when the number of process, conflict means what? Number of process try to access that hard disk at the same time, the confliction is occurring. So to avoid this situation, this type of situation, it should be predetermined policies to decide which request is handled first. Right? Either you can use the fast come fast service, or either you can use the priority basis, anything. Next is your virtual device. These are the devices are a combination of dedicated and shared devices. So a printer is a dedicated device, but using the spooling queues means it can be shared. A print job is not sent straight to the printer, Instead, it goes to the DEX or spool until it is fully prepared with all the necessary printer sequence and formatting, then it goes to the printer. That means when you put all the documents for printing purpose, it will be not directly moved to the printer area. You first would move into the spool or the temporary buffer area. Then after the fully prepared with the necessary sequence, picture sequence or formatting, then it goes to the printer level. So that is the virtual devices. So dedicated, share and the virtual. There are three type of devices there. Again repeating as a summary, dedicated is purely dedications to a particular process, but problem is that if process it is used frequently, then is fine. Otherwise, the wastage of the timing or wastage of the sharing system. That is another device is not using that system. Share device means it is shareable. More than one process can use that device, but sometimes there is some confliction when the number of processes try to access that particular device at the same time. So to avoid this problem, you should follow an algorithm, either first come first service or priority basis. Any algorithm should follow. Virtual device means it will be not directly first. That means whatever the request is generated from the particular process, not directly move to that particular device. There is a temporary buffer area where the request is stored, and after that, it will be moved to the particular devices. Next is your I/O request in operating system. I/O requests are managed by device types in collaboration with some system programs inside the I/O device. And the requests are served by the operating system using three simple segments: I/O traffic controller, I/O scheduler, and I/O device handler. I/O traffic controller keeps track of the status of all devices, control units, and communication channels. I/O scheduler, what are the I/O scheduler? Executes the policies used by operating system to allocate and access the device, control units, and communication channels. I/O device handler serves the device interrupts and heads the transfer of data. So these are the using three simple segments: I/O traffic controller, I/O scheduler, I/O device handler. I/O traffic controller keeps track of the status of all devices, control units, and communication channel. Is to control the traffic. Scheduler executes the policies used by operating system to allocate and access the device, control units, and communication channels. Then what is the I/O device handler? Serves the device interrupts and heads the transfer of data. So that is the I/O device handler. And I/O scheduling, what is the I/O scheduling operating system? Scheduling is used for efficient use of computer resource, avoiding deadlock and serving all process waiting in the queue. The I/O traffic controller has three main tasks. The primary task is to check if there is at least one path available. If there exists more than one path, it must decide which one is to be selected. If all paths are occupied, its task is to be analyzed which path will be available at the earliest. So that is the three main tasks. The major difference between process scheduler and I/O scheduler is that I/O requests are not preempted first thing. Once the channel program has started, it is allowed to continue to the completion. But some operating system allows I/O scheduler to serve an higher priority request. If an I/O request has higher priority, then they are served before other I/O requests with lower priority. I/O scheduler works in coordination with the I/O traffic controller to keep track of which path is being served for the current I/O request. Next, I/O device handler manage the I/O interrupts and scheduling algorithms. So in the next class, we have to discuss about the I/O handling algorithms. So for today's class, this is all about for today's class. Thank you.